divided by, what is it over, do I remember? 2a. Oh, 2a, right, I always forget it. So that's my quadratic equation. I put in my values for a, b, and c for that, and I'll get two values. I've already done this, so I'm just going to give you the answers, but then I'll show you an easier way to do it. 1.775 or 0.225. So t has two valid values, 1.775 or 0.225. Now, sometimes when we do this, we'll find that one value is negative. And you can't really have a negative time. So you're like, I'm just going to get rid of that. But that doesn't happen here. We have two positive values for the time. We have no reason to throw out either one of them. What are we going to do? Like, how are we going to figure out the time that it ends its trajectory? I'm sorry, I heard something about equation. It sounds like kinematics. What did you say?
Back in the original equation.
No, we're not going to do any equations. Let's just think. Brennan, did you have a... Cody? You could do that. Yeah, you could calculate the time to go up. We could do that, right? We could say that the velocity up here at the top is equal to 0, and then calculate the time up, and then say, well, whatever one is bigger than that. Is that what you're thinking, Cody? Could do that. There's a much easier way. We could just reason it out. These are two valid times. That is that the object is at 2 meters at 1.775 seconds and 0.225 seconds. So when is it at this position? The longer time. Because notice it has another position over here. And that's why we always get two times. Unless we're at the top, because it's there only once. So you do get two valid times. This time over here is 1.775 seconds, and then at this point over here is 0.225 seconds. Even though those look like two S's, one of them's a 5 and one of them's an S. Okay? Y'all with me on this? There's a quiz on it. Number 4 is almost identical to this. And if you don't like the quadratic, you know what? I don't like the quadratic either. So you can look up a quadratic equation calculator. How about Symbolab? No, not that one. I think this first one is good. Oh yeah, and then we just put in our values for A, B, and C. What was it? A 5, negative 10, and 2. And there's our times, 1.775 and 0.225. Just put in my values for A, B, and C, and then I get my two valid solutions to that equation. Okay? Yeah, Frank?
How did you come to use all the y components
from the very beginning? Like, why did I use V naught y instead of V naught x here? Because I'm looking for the time when I'm at a y position of 2 meters. So if I was asking you instead, what is the time when I'm at an x position, whatever it is over here, what is the time when I'm here, then I would use the x component. We're going to come back to this because we'll work a problem where I'm actually dealing with the x component of the velocity. But in this case, I was dealing with the y component of the velocity because I have the y displacement. And we want to keep those two separate, the x and the y values. Just treat them like two separate problems, and then you'll work on this one. Does that answer your question? Don't worry, we're not done with it. We're going to come back to it. Any other questions, folks? You look really excited about projectile motion. Are you just faking that? Yeah. Okay. All right. It is pretty remarkable that you can describe the positions of things and predict where they're going to be. My pastor was a soccer coach, like for little kids, and he said that even a 4-year-old can do projectile motion problems in his head. Right? Because you kick a ball, and you need to know what angle do you kick it, and with what speed do you give it in order for it to make the goal. So you can all kick a ball and roughly get it close to some, big goal. So you all know how to do projectile motion problems in your head, instantaneously, before you're not even thinking about it. Did you know that? You just don't use the numbers, right? You do it all sort of intuitively. All right, let's do some of these practice problems. Page 66. We'll try this first one. Soccer ball is kicked at an angle of 30 degrees. If it requires 1 second to reach the goal, what is its initial velocity? It's a little bit different than what we've done, but think about what you know. We're doing pretty well, actually. Surprised. I'm not surprised, because y'all are awesome. Feel free to ask your neighbor. Please do ask your neighbor that. I'll take that. I just want to, I'm not going to turn it off just yet, but I want to tell you, it takes 1 second to reach the goal. How long does it take to get up to the top of this trajectory? 0.5 seconds. So from up here to up here, it takes 0.5 seconds. Right? So I'm going to write that down. T top is 0.5 seconds. You might have worked this a little bit differently. It takes 0.5 seconds to get up to the top. Then you can find out what is the velocity in the y direction from this. And then you can find out what is the magnitude of the initial velocity. I'm going to stop in about 8 seconds. 3, 12. Okay, good. D is right. So this thing goes like this. Up here, t is equal to 0.5 seconds. And also, the velocity in the y direction equals 0. So I can say Vy equals V naught y plus Ay times t. That's going to be 0 equals V naught y minus 10 times 0.5 seconds. And so V naught y equals 5. So a lot of you put A because you probably just stopped right here. But that's not the right answer because I want to know what is its initial velocity. So I have to go 1 step further, and I say that V naught y is equal to V naught y is equal to V naught, the initial velocity, times the sine of the angle, which is 30 degrees. Sine of 30 is a half, and so 5 divided by 1/2 equals V naught. This is a half, and that's equal to 10. So D is the right answer here. Yeah.
Y would be 0.
Huh?
V naught Y would have to 0.
V naught Y is not 0 because here, let's step back. Like this problem is different from what we did because I sort of gave you the wrong information up front, but it's still a similar problem. Well, let's sort of work it the way we normally do. What we're saying here is that V naught is equal to 10. Sheldon, I see. Just a second, I'll get to you. V naught is equal to 10, and so I do have X and Y components here. I have to have a Y component because it goes up. So Vy can't be 0 here. Vy is 0 up at the top, but it's not 0 right here, which is what I'm dealing with. Did I answer your question? Are you sure? Can you restate? I'm not sure that is really.
Because I did it a different way rather than the same component. Just half because acceleration was negative 10, which came out to 10.
Yeah,
It wouldn't normally work.
I don't think so. Okay. Sheldon? V equals V naught plus AT. Is that what y'all did?
It's because the acceleration is 10.
That's what you did? Hold on, let me think for a second. No, I don't think that's going to work. I think it just works here. Is that what everybody did? You rascals. Yeah, that's what you were saying. No, that's not going to work. It's more complicated than that. I'm sorry. That would be nice, but no. China? Oh, I was solving here. Previously, we had found, like on a TV show, previously we had found that V naught was equal to 5, right? So we had solved here for V naught equals to 5. So I said 5 is equal to V naught times the sine of 30. And then I solved for V naught. Let me write it out in more detail. I said that 5 is equal to V naught sine of 30. And then I divide both sides by sine of 30. But sine of 30 is equal to a half, so that's where that half came from. Okay? That's a good problem, but it's a little bit different than one that we've seen. So you need to know how to do projectile motion problems backwards and forwards. Like take different pieces of information and be able to fill in information that you don't have. The homework and the quiz that's due tonight, they'll help you with that. But also look at some of the old test questions. You'll get ideas of the variations. Okay, this one is a little bit different too. You fire a projectile from a table as in this figure. If the y displacement is 1 meter, and the initial speed is 5 meters per second, how far does the projectile travel in the x direction? This is your lab. You have a lab just like this week, by the way. We're going to shoot people. Shoot little metal balls. I'm going to blank this for just a second. your first thing here will be to find the time. Your time is how far does it, how long does it take it from here down to here? It's just like if I drop something from 2 meters, or 1 meter rather, how long does it take to drop down 1 meter? That'll give you your time, and then once you find your time, you want to find the x range. That x is equal to vx times t. And you know vx, that's the velocity in the x direction. First find your time, then find your range. What's up, Maggie? Well, write down everything that you know, no problem, and the thing that you want to know. I'll help you out. Alright, so you want to write down, I'm going to help you a little bit with this. You write down everything that you know. First of all, I know that y is equal to 1 meter, right? Is it 1 meter? No, not really. It's really negative 1 meter, because I start up here at y naught equal to 0, and down here it's y equal to negative 1. Here we had problems like that before in chapter 2. We just need to make sure we keep our signs correct. So y is equal to negative 1. I also have this speed. I need to know something about that. So my initial velocity is equal to 5 meters per second. I don't have an angle given though. So is that initial velocity? What is that initial velocity? Is it some vector in some direction, or is it an x, or is it a y component? What direction is that v naught in? It's in the x direction. So in this case, there is no v naught y. There is only v naught x. So v naught y is equal to 0, because there's no component of the velocity, initially anyway, that's in the y direction. And then I also know the acceleration in the y direction is negative 10 meters per second squared. Okay? And now the two steps that you need to do is to find what is the time equal to for an object dropping 2 meters. Is it 2 meters? No, 1 meter, I'm sorry. How long does it take for an object to go 1 meter above the floor down to the floor? And once you find that time, that's the time, the hang time, if you will. In that time, it's able to travel a certain distance in the x direction. While you're working that, I'm going to write your equations over here. I'll give you a little bit of a start. How am I going to find my time, y'all? I'm dropping this thing from here to here. Which of these do I use to find my time? 1, 2, or 3? 1, 2, or 3? 3. I'm going to use 3. Because I have y. I have v naught y. It's equal to 0. I have that, and I have that. So all I'm missing is t. So I would say y equals v naught y, t plus 1/2 ay t squared. Here, v naught y is 0, so that whole thing goes away. I'll solve that for t. And then, once I find t, I want to know, with this speed, how far is it going to go in that amount of time? No acceleration, just travel along at 5 meters per second for a certain amount of time that's given by this. And then I can find the total x distance that it travels. All right, we're going to cut it off here in about 15 seconds. And you're doing this one in lab, this exact problem. I'm going to stop at 6:45. 6:45. Just guess if you're not sure. 6:45. A couple more seconds. Yeah, obviously you need to be faster. I know you're just learning this, but for the test you need to be faster at this. So B, I'm pretty sure that's right. 73% of people can't be wrong, can they? They can be, I guess. So let's try it. I don't know what the answer is right off. So y is equal to -1. That's equal to 1/2 of -10 times t squared. And then I solve that. T is equal to the square root of 1/5, or the square root of 0.2, which is 0.447 seconds. Keep more sig figs till we get to the end. And then I want to solve for x. X is equal to Vx times t. Just simple kinematics, no acceleration. It's just chugging along at 5 meters per second, or 0.45 seconds, or 0.447 seconds. And so that must be, what did we put? Oh yeah, so which is equal then to 2.3. All right, 2 steps. If your time's not given, your first step almost always is going to be to find the time. And there are some tricks to that. In this case, we had to use our y motion. And in most cases, you're going to use your y motion to find the time. And then use that time to figure out the x or the y position at a particular point. Maggie?
So it's usually the y that you use to find time?
Almost always, but I'm going to show you a problem. I think it might be the next one. I'm going to show you a problem where you don't use the y position, you use the x position. It's sort of just given by what you have in the problem. Caitlin. Sure. Because if we read up in the problem, it says you fire a projectile from a table. So it just says in the table. Now if I look at the table though, my velocity comes straight out. If it wasn't, like if it was some other way, it would be drawn like this, or it would be like have a ramp up like that, and I would give you some angle. Okay, is that clear? Any other questions? I think I have a couple more. We'll come back to that. Well, what do you do when there's no time? Well, let's do this problem first. Large cannon is fired over ground level from level ground an angle of 60 degrees above the horizontal. Muzzle speed, that's the initial velocity, is 100 meters per second. What maximum height will the projectile reach? Take a couple minutes. This is just like the Nicolas Cage problem, exactly like that. Your first step will be to find the time at the top. Actually, you'll need to find your x and y components. But then find the time at the top, and then find the height at that particular time. Goodness, bless you. You'll need to find your x and y components of the velocity. I'll give you the angle and the initial speed. Then you'll need to find the time that is elapsed when it gets to the top of the trajectory, or Or you can do it that other way if you want, and that's fine too, but I think it's probably easier. Find the time at the top. And then once you find that, you need to solve for y, finding the y values. We're going to write our little equations over here. I found zero x and you don't like. You can check yours against those. But now you need to find the time, and then you need to find the height at that particular time, at the time at the top. I'm going to do another minute or so. Class is mostly settled on the answer. I assume it's right. I don't know what the right answer is. Okay, we're going to stop at 5:25. 5:25. So just guess if you're not sure. You have 15 seconds. 5:25. Let's assume that's right. I'm going to go ahead and mark it right. Most use the A. I've written down a couple things. I found V0x and V0y here. Actually, we're not going to need V0x, but we will need V0y. I first want to find the time. So I say that Vy is equal to V0y plus AYT. This is Vy at the top. Because up here, Vy equals 0. And that's going to be one of our little tricks. When we need to find the time, and we know something about the y motion, then I can say the velocity at the top is equal to 0. So that 0 equals 87 minus 10, because ay is equal to negative 10, times t at the top. And then t top is 8.7. Y'all confirm that? Yeah, so that's 8.7 seconds. Now, step number 2 is I find what is this? What is the y position? And so I say V0y times t plus 1/2 ay t squared. I'm using the t top, which is this 8.7 seconds. So I say 87 times 8.7 minus 5. Remember, half of -10 right here is -5, so I carry down that -5 times 8.7 squared. And that should give me 378, which is 400 meters. You get 378. So A is the right answer. Aggie.
So you know you don't need B not X because you're looking for Y.
Right, I'm needing the Y. So I don't, in this problem I didn't have to deal with the X at all. But if I asked you instead for what is the maximum range, then you would need to know B naught X. Let's go ahead and work that problem too.
You would need Y.
You would need Y as well, actually, because you have to have the Y in order to find the time. Let's go ahead and do the range. Actually, no, let me hand back your text, because it'll take this one. Okay? All right, so the way to handing back tests, your grades aren't on them, so